Hi everyone, I'm Wendy and I'm a student at the Davidson Academy. This is my 5th year attending the DA, and I have therefore taken a number of science classes and found that Excel is a very powerful tool you can use in your lab reports. But when I got to the DA my first year, I had no idea how to use it, and it made my life a lot harder. So today I'm going to show you the basics of Excel and what tools you might need to use for science reports. Okay, so this is the general setup for Excel. All the tabs are at the top, and it's pretty similar to Word. So here you have all of your columns and rows, and here you have the ribbon, and you can minimize that or bring it back and then pin it over here. Here are your cells, you type in them. That part's pretty straightforward. Down here at the bottom, you can create multiple sheets. So if you want to create multiple layers of data, for example, you can press the plus button and create another sheet. I've created a couple sheets here with example data from labs I did in my physics class, and I'll use these to show you how to do stuff. So first of all, you can do some basic cell editing. So if you hover over the line between two cells, you can click it and drag it out to whatever width and length you want it to be. You can do that in both directions, like I said. So here I'm going to make this one a little shorter now that I've extended it. Alright, what I find most useful in Excel, especially for reports, is the equations function. So you can set cells equal to other things. So for example, I did a lab that this is the data from, where we hung different objects on strings and suspended them in water and air and took the tension force. So we were trying to determine the buoyancy force, which is how much the substance that they're in pushes up on them. So I have the tension force here, the data that I recorded, in air and in water. And to find the buoyancy force is the force of tension in air minus the force of tension in water. So I can do that in Excel. I don't have to pull out a calculator and calculate each one of these individual values for each of these trials. So I can actually just go equals to show that I want this cell to equal something else. And then I can click on this cell over here and it'll put it into the box. And then I can say minus and click on this cell here and it will put it into the box as well. And then I can just hit enter and it will calculate that value for me. So that gives me the buoyancy force right there. And then I don't actually have to hit equals and then click on these cells and minus again for all the other ones. I can just click on here, grab this little box at the corner, and drag it down as many cells as I want, and then let go of the mouse button. And it will calculate all of the other values for me as well, because it just goes row by row like that. So then you have these equations all calculated for you in less than half the time it would take you to do it on a standard calculator or in your head. Alright, so I'm going to show you another use of this function. I have some more data here from a different lab I did in physics, and this was about the air pressure and how that varies depending on how much air there is in the container you're testing the pressure in. So I have here on the left the amount of air particles, and here I have the pressure. So here you see I've done 3 trials with each air pressure, so I want to calculate the average pressure for that amount of particles. So I have some other headings over here, and I'm going to select these data points, and you can either use Control C if you have a Windows computer, or you can right click and say copy and just click on this cell over here and it'll paste them right there. And then for average pressure, I can again use an equation. I can press equals, and then if I type in all caps AV, it'll come up with some options that I might want to use after having typed AV. So I'm going to click on average right here because I want to average those numbers. So then it'll tell you right below it here how to use this average function. So it says number 1, comma, number 2. So I'm going to click on this cell because that's number 1, and then put a comma, and then click on this next cell, and then put another comma, and click on this next cell, and then I'm going to put a closing parenthesis because that says it's the average of those 3 numbers. I'm going to hit enter, and it then tells me the average of those numbers. And there are a number of other functions, not just the average function, that you can use with this formula creator. So then I'm going to drag it down. It'll do the average of all of those for me. Now that I have this data of the number of particles versus the average pressure, oftentimes you'll be asked in lab reports to create a graph of your data, or a graphical representation of your research. There's a pretty easy way to do that in Excel. So what I'm going to do is I'm going to click on this box here. I'm just going to use the arrow keys and shift to select all of these other cells in this table. And now that I've selected all of them, I can go to this insert tab here up at the top, and there are a bunch of charts that I can use over here. For this, I'm just plotting data points, so I'm going to go to this little icon right here, click the drop-down menu, and choose a scatter plot. And Excel will create a graph for you with the left column on the x-axis and the right column on the y-axis, and it automatically puts in those unit markers for you, and then it plots the points for you. You can click in the top and rename it. You can also click anywhere on it and then click the outside points and drag it to whatever size you want, and it will increase the entire chart size for you. You can change the layout and style of the chart up here at the top, but I'm just going to use the default for now. And then there's this little plus over here, which will be useful for all the other things you need to do for a chart. So you can click on it, then you can create things like axis titles. That will give you these titles down here that you can label your axes with. So this axis is the number of particles, and this axis is the average pressure. So then you can also create a line of best fit if you're looking for an equation to describe, for example, the relationship between the number of particles and the average pressure of this air. So you can go over here to this plus again and go down to where it says trend line, press the little arrow out and click more options. And that should pull up this thing on the right. And then this relationship is linear, so I'm going to click linear, but you can choose any of these other trend line types. Alright, so then I want to find out what the equation of this line is, so you can compare it to other lines you might have, or just so you know what the relationship is you're dealing with. So you can click display equation on chart right there, and it'll pop up over here, and you can edit that later. The other thing that I want to talk about with graphs is the r-squared value. So you can click that, and it will tell you how well this line of best fit that Excel has created for you fits your data points. So since this line that they've created for this particular graph goes through almost all of these data points pretty well. The R-squared value is very close to 1. So the closer to 1 it is, the more precise your data is. So it is 0.9998, which means my data is pretty precise. So then you can click on this little box. You can drag it around. You can edit it as well. So we know that on the y-axis is the average pressure. So we can say average pressure. And then over here we know the x-axis is the number of particles. You can edit that as you want, and that'll make a graph. Now that you have this graph, you can put it into either Word or Google Docs or whatever you're using to write your report, and it will still work there. If you put it into Word, it will still be editable actually in Word. It won't be if you put it into Google Docs though. So I can click on this chart, I can right click and say copy or say Control V and go over here into Word and actually just paste it again, or Control C, sorry. And it will paste here, but then it will still be editable. So I can click in here and type, and I can still add to the chart elements. If you put it in Google Docs, you can still re-edit it in Excel and then put it back into Google Docs again, but you don't get the same level of editability that you do in Word because Excel and Word are both Microsoft products. So the only other thing is remember to save your Excel document often in case your computer dies or you accidentally close it. You don't want to lose any of that. And also remember to save it with a good name that describes what the file is, so you don't have to spend hours looking through all of your Excel sheets trying to remember what this is. Like lab data 5 is not the greatest because maybe you've had more than one lab and more than 5 data points or things like that. So just remember to save always. If you have any more questions, please ask your teacher or ask her to give you my contact information, and you can ask me and I will do my best to answer any of them.